Welcome to Excel Formulas. In this class, we're going to discuss formulas, starting out at the beginning, learning the basics, the rules required in creating them, and errors that can come up, and then going on to more advanced topics like referencing things in multiple worksheets or workbooks, using conditional formulas that analyze the data and do one of two or more different things, and controlling the appearance and the structure of the formulas with some of the built-in tools that Excel provides. Before we do that, I do want to show you the resources that we're going to use in class tonight. So if you go to our library's website, that's mybpl.org, and go to Services, Computers, and then go to Computer Classes, you will see under Classes and Materials all of the classes that we have been providing for you online so far. And you can see the Excel Formulas handout that I'm going to be going through tonight, and the Excel Formulas class project and branch office Excel files that you can work with at home. Just so you know, we'll be using Excel 2016 in this class, but everything that we work on should work with any version of Excel going back to 2007 when they added the ribbon, and going forward to Office 365 or Excel 2019. Now, I would recommend, if you like to play along, that you open up both the branch office file and the class project file so you have them open and ready to go. But I will say that we're only going to use the branch office once over the course of the class today. So if you want to simplify it, you can skip that. Now, I'm going to work here with the Basic Formulas tab, and we're going to go over some of the rules that you would use in creating formulas, and then we will go through different errors that can come up. I'm going to be typing things in the side here, giving examples and demonstrations as we go through this. But if at any time I want to add more to it, I will add a couple of extra things here. You do not necessarily need to type along or play along with these, but feel free if you want to. So, starting at the beginning, one of the first things I always mention is that all formulas begin with an equal sign. You can see I demonstrated this up here. If you simply type in 2 plus 2, it doesn't do anything in Excel. But if you type in equals 2 plus 2, you get the formula result there. This is something that you're going to do over and over again. It might seem simple, but it is a very common error and something that comes up a lot when I'm going through people's work and trying to debug mistakes that they made. Very easy thing to miss. The other thing that I want to mention about the equal sign is that you can only have one in your formula. If you have a second one, then that formula suddenly becomes a test to see whether it's true or false that one side of the equation is equal to the other. That's what the equal sign means. We very rarely want to do that. Occasionally, if you are working with a conditional function like the if statement that we're going to look at later on, you want to run a test and you'll use the equal sign there. But the vast majority of the time, you're just going to have the one equal sign at the beginning, no matter how long and complicated your formula is. Now, the next thing that I mentioned is that formulas can use cell references and or real numbers in their calculations. So you see this formula uses real numbers, equals 2 plus 2. This formula also uses real numbers, equals 2 plus 4. But if I change this to equals 2 plus G5, it still works. See, G5 is a cell reference to the one right above there, and that tells me 6. More often than not, we're going to want to use cell references in our formulas. That allows the formulas to be adaptable if the information changes. So if this comes along and becomes 5, the formula changes right with it. It also allows you to reuse formulas like we have here, where I said equals B4 divided by C4, and I then copied those down to the next one, so it became B5 divided by C5, and divided by C6, and so on as you go on down. If I had typed in equals 271 divided by 9, the first result would be the same, but copying and pasting on down wouldn't do anything. As opposed to when I type in equals B4 divided by C4, when I copy and paste on down, it continues to work. So you see the cell references are generally preferred. There are times when you might want to use specific numbers. Say, for example, you have a fixed rate of interest that you're trying to apply to everything in your formula and that's not going to change. Or if you're calculating something in with the number of months in the year or something else that is a set number and you just want to have that as part of your equation, that's perfectly fine. But most of the time, we're going to do these cell references. Now, the next rule that I talk about is I go over mathematical operators that you can have in Excel. I give the example here of the operators that we have available to us. After we type in the equal sign, we use the plus symbol, then the dash for the subtraction, the asterisk for multiplication. So you notice you're not typing in an X or using parentheses next to each other, other formats that you might be familiar with. The forward slash for division. That is the key that is shared with the question mark. It's not the key that is above the enter key on your keyboard. That's the backslash. Then the caret for exponentiation. So that's if you want to square or cube or raise a number to another power, you'd use the caret symbol there. After that, I talk about how you can use parentheses to override the order of operations. So if you wanted to control what things happen, the order of operations, you might remember this from math class, begins with exponentiation first. That's what happens first in the equation. Then multiplication and division, reading from left to right. So in this case, the multiplication would happen first because it's on the left-hand side, but it has no preference over division in the order of operations. And then finally, addition and subtraction would be the last things to happen, again, reading left to right in the order that they occur. But if you want to control that, you could say first, put in parentheses, and so 2 plus 2 will now be the first thing that happens. After that, it will subtract this number. And you see we get a very different result there. You could put in these parentheses next. That doesn't change it because that's the same order of operations there. But if I put in, these, suddenly that happens before the exponentiation, and we get a different result. The most common example that I give for this is if you're averaging numbers. You see this with the parentheses around the numbers added together will work properly because it will add together all of the numbers here and then divide them by 4 if I was trying to figure out the average number of sales for all my 4 made-up salesmen. If I get rid of those parentheses, it will do the division first, and then that doesn't work. So we put in the parentheses to control what order we want things to happen in. Okay. Next rule that I mentioned is after you have entered in a formula, you can edit it either in the formula bar up here at the top, you see it right there, or you can double click on the cell and edit it right there. Whichever you prefer is entirely up to you. It's a matter of personal preference. Typically, I will edit things right in the worksheet. I find that easier to understand, but I'm amongst the middle of it. But if you have a longer formula, sometimes it can be hard to read if there's data alongside it or other formulas around it. And so the formula bar can be a nice, clear, open place to read. If you want to see all of the formulas that are entered in, Control and the tick mark. The tick mark is the one above the tab key to the left of the number 1 on your keyboard. Shows you all of the formulas in your worksheet at once. If you did that along with me and nothing changed in the appearance except the columns got a little wider, that simply means you haven't typed in the formulas yet. So Control tick turns it on, and Control tick again turns it off. It is a toggle. That means you press it once to turn it on, press it again to turn it off. Why would you do this? I mean, most of the time we want to have the results visible for the formulas, so that's what we're going to want to have there. But if you're trying to see where the data came from, maybe somebody handed you a spreadsheet that was created by someone else, and you want to track down where are these links from, where does this data come from, and it's hard to see everything at once, the Control tick can allow you to see all of the formulas in your worksheet at one time. So something to be aware of. Okay, so those are some of the basic tools that we use when working with formulas. Now let's take a look at some of the error values that come up. For those who like to follow along, we're on page 2 of the handout, and we're going to be going over the different error messages that come up, what they mean, and what the solution to them is. Now, the first one is the most straightforward, and it's probably the most common one you're going to see. That is when there's not room enough in the spreadsheet to fit the result. Let me demonstrate here. So you can see when the result doesn't fit inside the column, you'll get the series of pound symbols there. That indicates that you just need to widen the column. This is one of the more straightforward ones that comes up. Now, this I most often see when I'm making formatting changes, like adjusting the date and time to something that spreads out a little wider and requires more space, but it can come up with formula results too. Those of you that have experience with Excel, you might say, hey, most of the time when there isn't room in a column, it just cuts off the cell wherever it runs out of space. Why doesn't it do the same thing for the formulas? Well, they don't give any explanation for this, but my understanding has always been the result of a formula is more dramatically changed by the loss of one character than the amount of text that comes in here. If you imagine the difference between 262 and 26, that's a little bit more significant than losing a letter off the end of a person's name. So whatever the reason for it is, if you see those pound symbols, all you need to do is widen the column. So that's a pretty easy one. Now, another error that you're going to see occasionally is the value error. You see pound sign value. By the way, when I say an error value, what I mean is when the formula returns something instead of a result, like we see right here, it returns an error message that is indicated by the pound sign and then some message that comes after it. That does not mean that every formula that returns a result is correct. You should always double check your work and make sure that the formula result makes sense in the circumstances that you're calculating it. And if possible, if you're using the formula multiple times, calculate it yourself the first 1 or 2 times to make sure that it's working the way it's expected to, and then go through and use it automatically the rest of the time there. Because it's very possible to write a working formula that is not logically set up correct and will get you the wrong information in return. But when you see one of these error messages like we have here, that means that the formula itself is not functional for whatever reason. In this case, is giving a value error, which means that the wrong type of argument or operand is being used. Arguments are the information being put in. That's the cell references that you give it. Operands are the tools that you are using on the data. That's the plus symbol or the ampersand or the multiplication symbol, the asterisk, whatever it might be. So when you get that value error, it means either you're using the wrong kind of calculator, something like that, or you're putting the wrong data into it. In this case, we put the wrong data into it. I accidentally said D3 instead of D4. And most of the time, that's all there's going to be to it. It's going to be a typo. Very often, if you have ranges of data, you're going to grab the wrong spot with your range, and you want to watch out for that. But you can just double click on it after you get the error menu, or sorry, the error response, and then correct the data, and there you go. Now it works. So be aware of that. Make those changes pretty quickly whenever necessary. That's usually all there's going to be to it. Sometimes it might mean you chose the wrong function and it does not, it's asking for the kind of data that's not appropriate for what you've put in there. But most of the time it's going to be you accidentally got one row too high and you grabbed the label instead of the value, or there was some bit of data in the middle of all of your long row of numbers or your long column of numbers, and it grabbed that bit of text in the middle there that somebody typed accidentally, and that's causing the error. So something to watch out for, but usually not too difficult to solve. Now, the next one that I want to discuss is a little bit more interesting. That's a divide by zero error. What's interesting about these is they sometimes come up when you did everything right with the formula. Take, for example, this formula that I have here that is calculating the average number of sales per year. So if we think about this logically, the sales per year should be the number of sales divided by the number of years. And if we have that entered in and that formula written, it works great. But what if you created the formula before all the data was entered in and these numbers weren't there? Well, then you'd get a divide by zero error because you're taking the number of sales right there divided by the number of years, which is currently 0. You can't do that. Anything divided by 0 equals infinity, and infinity is the sort of thing that makes computer programs lock up. And so it gives you an error and just stops that from calculating. Now, what you do in this situation depends on who this spreadsheet is for. If this is for you or for somebody else that wouldn't really care about the appearance, you can just ignore the error and wait till the data is typed in, and as soon as it is, the error will go away. But if this is going to be given to perhaps a coworker who would be confused by the error that's there, or a supervisor that wants this to look a little bit nicer, you might need to do something more sophisticated. In that situation, I would recommend putting in what we'd learn about later called an if statement that will test to see if anything is typed in here. And until something is typed in, it will not perform the calculation. And then once you have data entered in, it will give you the result. That's a little bit complicated for this point, but the main thing that I want you to understand is if you see that divide by zero error, look at how you've written out the formula, make sure it's correct, and it might be just fine and just be waiting for the data that's entered in. Okay. Next one I want to mention is the name error. Now, the name error is something that we used to see more often. Excel used to be a little bit dumber about this, and if when you went to go type in C4 plus C5, you accidentally typed C4 plus 5C, it would give you an error. Excel has gotten a little bit more clever, and now it says, hey, we found a typo in your formula, we want to correct it. Do you want to accept this? Yes, all better. Fixes it for you straight away. Where you're likely to see the name error these days is if you're making a reference to another worksheet and you say, forget to put the exclamation point in that we'll learn about in just a few minutes, or you make a typo in the name or forget to put single quotes around it if there's a space in the names. All these little mistakes that you can make can cause a naming error. And so that's usually just a typing mistake in the reference. We'll learn about names later on when we talk about naming range examples. And in those situations, you can also have this error come up. But usually is a matter of going back, looking over your formula as written, and finding what cell you're referring to that you are not referring to correctly. So just keep an eye out for that. I have a couple more errors listed in the handout that you're not likely to come across, but I do want to mention the circular error because it can be a little bit disturbing. When you make a circular error, what you're doing is you're having a formula refer to itself. This doesn't come up that often. Usually it's if you screw up a range and you have the range go across too many cells and you accidentally grab the cell that you are typing it into. But as soon as you get a circular error, that is going to pop up an error message right across the middle of the screen and say, nope, we can't do that because you have typed in something that would have it adding it to itself over and over and over again, and that immediately would lock up the computer and freeze it. So it'll recognize that and break it. You just need to go in and check the arguments that are submitted and see where the reference to itself exists. So if I, for example, we're going to have this equal the sum of B4 through B7, but I accidentally typed 77, you see that's going through all of those numbers, including the cell where the result is at. So it would give me the result of this, whatever that is, somewhere in the neighborhood of 800, and then it would add that to itself. So suddenly it would be 1600, and then it would add it to itself, and suddenly it's 3200, and that would keep on going forever. So it can't do that, and it will immediately, when I press enter, give me this circular reference. So I say, okay, you notice it just puts a 0 there. I go back and say, oops, I typed B77 instead of 7. I delete that, and everything is better. So that's what a circular error is, something to watch out for. It's not going to come up that often, but anything that pops up those big scary error messages in the middle of the screen, I like to mention to students just so that they're not thrown by it if it happens to come up. So those are some of the main error messages that you're likely to see. I've mentioned a couple others there just in case you come across them. Something to keep an eye out for, but I don't think you'll run into that often. Now I do want to talk about using functions. I already did a quick demo of it right there. I'm going to delete that and walk through this a little bit slower. Functions are a kind of formula that is built into Excel and that you can use on your own whenever you would save time by doing it. You can always write your own formulas, typing them out like I did in the examples earlier, but sometimes they have built-in functions that work better and faster for you and are a great thing to use. You can use these either by typing them in, as I just did, or you can use the Insert Function menu item in the Formulas tab. That will save you a little confusion or time. So let's go through that one first. If I want to write something that will add all of these together, I could simply type in equals B4 plus B5 plus B6 and so on. But if you have, instead of 4 of them, 400 of them, that suddenly stops being practical. And we want to use a range that will get everything in between two brackets that we put in. So I go to the Formulas tab here at the top, and I click Insert Function. That's that first button in the upper left-hand corner. If you have a much older version of Excel, 2002 or 2003, you would go to the Insert menu and choose Function. But from 2007 on, which in all likelihood is what you have these days, you go to the Formulas tab and find Insert Function there. Now, when you open up this window, you see two different ways to find the function. You can either type in a description of it here, or you can choose by category. Most of the time, what we want is going to be in most recently used. We're all creatures of habit, and we use the same things over and over again. Now, you might say, I've never used a function before. How would it have anything in most recently used? If you haven't used a function before, then it would be the most commonly used functions by people in general would be listed there. And you'll see sum right at the top of that. Sum is adding together all the numbers in a range of cells that you're going to provide. That's the one that we're going to use more than anything else. But if you're looking for something more obscure, maybe you work in finance or in engineering and you want to find some specific functions for that, you go into the pull-down menu here and you can choose different categories that are available and simply look through all of the different functions that they have. Each one of these will have a description of it, and if you want a more detailed description, you can click Help on this function, and it will pop up some more descriptions there. You can see they have a lot more information and usually some examples of how to use this. If you want even more specifics on a function, places like Google and YouTube often have good resources on how to use some of the more common and more complicated functions that are available. But for what we're doing today, most recently used functions can work out pretty well, and we want the sum function. Notice, by the way, I didn't go over how to use the typing and description in there. You can do that if you want to. I haven't had the most success with this. When I type in a description of what I want to do, it doesn't always grab the function that I'm looking for. I've been happier with using the categories, but by all means, try to give a search in there and see what you can find if you want to give that an attempt. I click OK here, and it's asking me for the arguments, which is what cells do you want to add. Excel will always guess. About half the time it gets it right. This time it got it mostly right. You see it said B4 through B8. So that would be that cell down to there. We don't actually need B8, so if I wanted to be a stickler, I could change that to B7. But the B8 is a 0, so it would have worked okay that way too. You might be a little confused by the number 2 option here. You say, hey, that's 4 numbers. What do you mean number 2? This is a second group of cells. So if, for example, you had a range of cells over here that you wanted to add up that were not connected at all to your first ones, you might click in here and say, N4 through N7. And that would get a whole other group of cells. Now, obviously, in this case, I don't have those, so that's not very helpful. But there are times when that might be useful for you. And you see, as soon as you start entering something in there, number 3 becomes available as well. So you can have lots and lots of groups of cells. most often you're going to have just one range of cells, either a column going up and down or a row going sideways that you want to add together. So once that's done, I click OK, and you're going to see the results will appear down there. If you wanted more help on the function, you do have that feature available here that will give those examples that we saw before. I'm going to click OK here, and we see the result. And as we see that, we see the formula written out in the top here. We see it still follows all the rules, has the equal sign right at the beginning, and then you see the word sum, and then in parentheses, B4 colon B7. If you ever wanted to type this yourself, it's important to get all these details right. A lot of times when I give examples in my classes, I say there's nothing magical about this. There's just a name that I typed in. In this situation, these are special words. These are names that Excel recognizes and it knows what to do with. So the name of a function is a built-in thing for Excel, and it knows that SUM means the sum function. That means it's adding things together. But you still need to have these parentheses or it will not work. So if I were to type equals sum B4 colon B7, that wouldn't work. You need to have the parentheses, and inside the parentheses go the arguments. The arguments are the information that you put into a function, and the function then returns the result. In this case, the result is 821. So that is how you use a function that is built in. There are more than 1,000 built-in functions. You are by no means expected to know all of them, but we have them there available for you and for whatever you specifically like to do. So what if you work in banking, if you work with a lot of timestamps or things like that that you want to put in, there are a whole lot of functions there. If you go back and watch the Excel 3 video, I do a number of the useful functions just to give you some different examples with that. Later on in the class, we're going to go over a couple other functions as well, so you're going to see some more of that there. Let's talk about referencing values in other worksheets and workbooks. So what we're doing with this is we are going to be creating links to other worksheets, which are the tabs at the bottom, or a workbook, which is an entirely different file. You would do this if you wanted to pull information from one spot to a whole bunch of others, or from a whole bunch of other spots and consolidate it into just one. So the example I'm going to give here is I'm going to take the sales from both branches. This is, of course, made up numbers, but I'm going to have my one branch here. I'm going to take those sales, and I'm going to get the sales from my other file, my branch office right there, and I want to combine them into one place. I can do that by linking them. Now, there are a lot of different ways to do this. You can copy and then paste special, and that creates a link. I did that in the Excel 2 class. I showed how to use the copy and paste special. You can also type in the details of it by typing in the formula. In my experience, there is a lot of room for error with that. I do have in the handout on page 3 and 4 a generic description of how you would type in the cell references for creating links from worksheets and links from other files. What I think is most likely to work for you is to use a combination of typing in the formulas and selecting the cells that you want with your mouse. So watch what I'm going to do here. I'm going to add together the total in basic formulas and the total from the other file. I'm going to do that by beginning, as I do all formulas, with an equal sign. And then I will take my mouse and I'm going to click here on basic formulas. Now, when I do that, it looks like we have changed worksheets that we're focusing on. But if you look closely at the bottom, you see linking in functions is still highlighted down there. And at the top, my formula now says equals basic formulas, exclamation point. I'm going to talk for a second about what we're looking at here. The single quote around basic formulas indicates that that whole thing is the worksheet name. You need those single quotes because there's a space in this name here. I named these worksheets to indicate what we're going to be doing in class. With your own spreadsheets, I would strongly encourage you not to have spaces in the names. It complicates writing formulas. So I would have, if you have numbers or multiple words, that's fine, but just squeeze them together without any spaces. They'll work better that way. If you want to put an underscore in it so that it's easier to read, that's fine too. But when you put in spaces, then you need to have these quotes so that it knows to group it together. You then need the exclamation point to indicate to Excel that this is not a name of a cell range, that this is a name of a worksheet, like we see right there. So that exclamation point is absolutely key. After that, you're going to have the cell reference when I click on right there, and it says cell reference B9. So what this did is it made it more complicated. We've written formulas before where we just said equals B4 divided by C4, and that was referring to cells within the same worksheet. We added another layer of complexity here by adding the worksheet name in front of it so that it could refer to something on an entirely different worksheet than where it was. Next, I'm going to type the plus symbol, and then we're going to add one more layer of complexity referring to a different file altogether. Now, I mentioned this in my Excel 2 class, and I'll say it again here. I recommend against doing this if you can avoid it. Referring to things that are in other workbooks, that means other files, is dangerous because if these files get moved or renamed, that is something that Excel is not smart enough to figure out. If something gets moved around in Windows, put in a different folder, whatever it might be, Excel will suddenly have the link break and it will no longer be able to get this data for you. So avoid this whenever possible, but if just the structure of your organization requires you to have information in different files and have it all pulled together in one place, this is how you would do it. You could type in the name of the file, then the name of the worksheet, and then the name of the cell. There's a lot of detail with that and a lot of things you can get wrong. Again, on page 4 of your handout, I have the generalized structure for it, but that is ignoring all of the data path things and stuff that you would have to do depending on where the file was stored. So I find it much easier to have both files open, go over to the one in question, and when I select the cell, see how it fills in brackets, the file name, close brackets, and then the worksheet name down there. You see that does not require the single quotes because it's all one word. And then finally, after the exclamation point, the cell reference. You notice the $ in front of the B and the $ in front of the 1. That means it's absolute. And if this file were to, or this formula were to be copied and pasted, it would not adjust the column letter or row number as it was moving around. Now, one other thing I want to point out, this file name here, it looks relatively simple to have it just typed in. That's because both of these files are stored in the same folder on the same computer. If you had a file that was stored in, say, a network location or in a different folder or in a different user location on the same computer, you'd have a really long name here. It might be something like C:/users/the username/documents/the file name, and you need to make sure you get the extension correct and all of that. So a lot of room for error. I strongly encourage you to use the mouse clicking instead because it's much simpler. After I'm done with that, if I had more to add, I could type another plus or whatever other operations I wanted to do. But we're all done, so I press enter, and it jumps back to where we were before, and it gives me the result. So again, we could type all of this in, but the way I recommend you do it is you type in the operators that you want to do, and then use the mouse to click on these cells that you want to include in there. So that's how you create linking and functions and reference values that are in other worksheets, which are the tabs at the bottom, or workbooks, which are entirely different files. Now, we've talked a couple of times over the course of the class about range names, naming cells or groups of cells, something that we can refer to later on. I want to give us an actual example of how that's used and when that would be helpful. So here I created a mortgage calculation. Nothing too terribly complicated here. I started out with an initial balance and a monthly payment, and I'm calculating the interest by taking the initial balance times the interest rate divided by 12 and subtracting the payments. But look at a couple things we have here. I have created some named ranges. Now, the way you do this, the way you name any range, is you click on the cell that you want to name, and then you go to the left-hand side and you type in a name for it. So for example, if I wanted to change this, where right now it says A4, which is the column letter and the row number, I could click there and call this starting date. Now, one thing I want to point out to you, I made that all one word because that is a requirement for the names. Here are the rules for creating a name. Number 1, it cannot be a duplicate. They all need to be unique. Number 2, it can have letters and numbers, but it has to begin with a letter. So I could do for starting date, but it would have to be spelled out the word for, or I could do starting for, and you could have the number in there. You just can't begin with a number. And number 3, you cannot have any spaces. So we have to have it all one word when we go through that. And once I've done that and I press enter, I could now refer to that anywhere equals starting date. Now that, of course, acted strange because I have a date format there and a number there, so that was a bad example. But you can refer to that name anywhere throughout your workbook. And notice I said workbook, not worksheet, because you can refer to these things in other tabs as well. Now you see what I've done here is I've created the names interest to refer to this percentage here, payment to refer to this cell, and extra to balance to refer to this cell. So if I were to change this to 100, all of a sudden all of my payments change. If I were to change this interest rate to 425, all of a sudden the amount that I owe changes. And so by creating these fixed cells, I can tinker with the numbers here, and it will change the formulas as we go through. So that way, when I copy and paste this formula on down, row after row, it will not adjust these numbers on down. It will stay in one place. It stays fixed. And I don't have to have it memorized as to what these cell references are if I make changes later on. So if I were experimenting with this and seeing how long until I get the mortgage paid off, okay, we are in September of 2040 there. What if I change the extra to 200? That pays it off 2 years earlier. So I can tinker with things there all that I like. But the idea is I assigned these names to different cells. This is not something you do for most formulas. It's something that is needed in certain situations where you want to be able to refer to a value over and over again and not have it move around or have it fixed. You'll sometimes use this when creating tables. I'm going to show you when we do the invoice examples that I'm going to do in just a few minutes. It can be useful there. If you are wondering, hey, how do I find out what names are what, or which ones I've created? If I was tinkering here and I made this nonsense one that I want to get rid of, how do I do that? The answer to that is in the Formulas tab, Name Manager right there in the middle, and you can see all of the names that are in this worksheet. So I could select starting date and say, you know what, I don't need that, delete it. Am I sure? Yes, I am. Okay. And I can see the other ones that I've created, and it will tell me what it refers to. I need to make it a little wider to see the whole reference there. I can see what the current value is. That matches up with all of those. And if I wanted to edit that, I could click on Edit, and I could change which cell it refers to. I could put in a comment to explain it. I could change the name if I thought that was appropriate, whatever I wanted to do. So those are naming ranges. I'd encourage you to experiment with that a little bit and play around with it. It's not something, again, that you need every worksheet, but every now and then, it's not something you need every formula or every worksheet, but every now and then it can be helpful. Okay, let's talk about logical functions. This is the next big step in writing formulas and functions, and I want to spend some time on this and make sure that we have a pretty good understanding of how this works. This allows Excel to go beyond just dynamically reacting to the changes in information that you put in there and giving you different results, but it allows it to actually perform different choices and different functions based on the information that's in there. Now, I'm going to show you an example of this, and it's going to be a rather long and convoluted one. And we're going to go over how this works just so we get a good feel for how the branching and the options that are available for you with dynamic functions work. What I put together here is I created an invoice, and this is going to create options where when people put in an item number, it will give different names and prices based on that number that was put in here. Some of you that might have experience with VLOOKUP or other tools might say, hey, this isn't the best way to do it. I know. I just wanted to show you some tricks that we can do and things that we can do with the if statement. Now, to show you where this information is coming from, I created an inventory tab right here where my imaginary store has 5 different items with these 5 different prices. So back here at the invoice, right here is just a number that's typed in. And watch what happens if I change this. I press 2, that changes this to bird bath and changes that price to 205. If I do 3, batteries, and so on. 4, TiVo and the price. 5, plastic flamingos and the price. 6, invalid entry. If it's blank, everything stays blank. Let's say 1, that comes back to being a value there. So how's that work? What's going on there? Well, if we highlight either of these 2 cells, we'll see examples of it. And this is a great example of what I talked about earlier when I said when you have a long and complicated formula, like so, it can be easier to look at it in the formula bar than in the middle of the page. This kind of hard to read. Up here, not simple, but definitely easier. So what's going on here? The if function is what we're using with this. There are a lot of different ways you could approach this problem, a lot of different things you can do. I'm using the if function here because this is a really important one and really versatile for doing a lot of different things. I mentioned near the start of the class that the if function was a good thing to use to avoid divide by 0 errors. If you wanted to avoid having problems like that, you can put if in, and that will sidestep some of that so that it will not do the calculations yet. How does this work? Let me show you. When I click here, Excel provides me a description of the if statement, and it shows what the arguments are that are going into this. Now, so far in class, we've only done the very basic sum function, and the sum function is nice in that it says for the arguments with the sum function, you just want to have the numbers that you're adding together. It doesn't matter what order you put them in, it just wants a bunch of numbers given. That's a nice thing about addition. 2 plus 4 is the same thing as 4 plus 2, so you can put the arguments in any way you like and it all works out. That is not true with a lot of our more complicated functions, including the if statement. Here we have arguments that we want to put in, and it has 3 things that we need to enter in, and you have to enter them in the correct order. The first one is the logical test. So this is a test that Excel is going to do, and based on the results, it's going to either return the value if that test is true. It's going to return this middle value here. If that test comes back false, it's going to return the second one that you provide in the third space here in our function. So it's got a test, and then it is branching off. Think of it as a tree where if it's true, it goes one way. If it's false, it goes the other. So what did we do here? I created the logical test. If A4, that's this cell right here, equals 1, then the inventory is then, so if that's true, the result is you go to inventory and you return B4. So it goes to this worksheet and pulls back the value B4, which is umbrella. If that is false, so if A1 equals anything else, anything but the number 1, then it returns the second value if false. Now, what I did to make this a little bit trickier is in the second value if false, I put in another if statement. So if it is true, it returns umbrella. If it is false, it does this test again. If it's false, it says, okay, let's do another if statement. Does this equal 2? No, it does not. If it does, it would return this value. If it does not, it would, another if statement. And then I have it doing that test again. And if that comes back, then you have 3. So if we again imagine we have our tree here, the first one, if it's true, it does that. If it's false, it goes to here, and then there are another set of choices. True goes that direction, false goes that way. Another set of choices. And it just keeps branching off with other options back and forth. Now, an if statement does not need to be this complicated. It could just be 2 simple things. If it's true, do one. If it's false, do the other. It does not need to be these nested functions that I have where there's one inside of another, like the Russian nesting dolls where you have the smaller statue inside of another smaller statue over and over again. But I use that as an example of how you can do complicated things using the if statement. So a test to see if it's a 3. Is it a 3? Yes, return that. No, do another test. If it's a 4, return that. If not, do another test. If is it a 5, return that. If not, do a last test. If it's blank, return nothing. If it's anything but blank, return invalid entry. So that means if you've gone through all the possible choices and it didn't have any of them, simply return this data. One last thing that I want to point out with this function is we have a whole bunch of parentheses here at the end. For every time you open parentheses, you need to close them. So that parentheses goes with that one. That one goes with the next, and so on and so on and so on. You notice that they're color-coded to match up with all of them here. That happens automatically. It's something Excel provides for clarity. So that's what we have as a use for the if statement with all of the nested functions. If we were to look at the price, it would be the same thing, except instead of returning this value, it's returning this one, and so on through it. Is this the only way to do this invoice function? Absolutely not. This is just one thing that I'm showing you with the if statement that you can do. If you go to the Excel 3 class, I show you in that video how to use the sum if statement, which allows you to go through and to add things together based on a test that you provide. There are a lot of other variations of these logical tests that are in there. I just wanted to introduce this to you and show you how you can work through it to figure out how to give Excel options based on the data that's put in there. So if you wanted to have different results come back based on different area codes that people put in and move the data into different directions that way, you can do that. If you wanted to have different results come back based on the name of the salesperson that was typed in, you can do that too. There are a lot of options that you have with the if statement. It's a very versatile tool and one that I'd absolutely recommend playing around with and exploring. It can be a little frustrating at first. Sometimes these tests don't work exactly as you wanted them to, but by all means, try it out and work with it. I think it's a really useful function for you. Beyond that, I have some other examples of here an if statement here where it's testing to see if there is any price at all entered in here. If there is not, it puts a blank space. If there is, it does a multiplication times the quantity with that. So that way with this one, even that there's nothing typed in here yet, so there's no result, it just sits blank. But as soon as I put in item number 3, it automatically calculates it for me. So a lot of things that we can do with the if statement. This is obviously a simpler example of the same thing. Simpler example, I should say, of the same thing. That is the if statement there. Now, because, as I mentioned before, this isn't the most efficient way to create an invoice example, I did want to show you a simpler version of it on VLOOKUP using the same inventory that we have here and getting the same results. I just use the VLOOKUP statement. I say, take the value in A4, so that's the number right there, throw it into the inventory table, which is in this tab, this range here, bring back the value in cell 2, or in column 2, I should say. That's right here. And then finally, do I want it to give range results? And the answer is false. I want this to give exact results. So it has to match the item number for it to bring back the result here. And notice that when I do the price, I just change, everything stays the same except this 2 becomes a 3 because I want the price to bring back this column. That's the 1, 2, 3 column instead of this column, which is the 1, 2 column of that. So you see, for this example, VLOOKUP works a whole lot better than the if statement. But there are situations where the if statement will do things that VLOOKUP cannot. So a couple of key functions that I would strongly encourage you to learn about, but you have to use whichever one is appropriate for the data that you're working with. Finally, I'd like to talk about a couple of tools that Excel provides that, while not directly formulas, can relate to our working with formulas and how we control the data that comes in. The first one that I want to talk about is data validation. You can use this to control what inputs are allowable by the user. So if you are setting up formulas and somebody else is going to come along and fill in the actual data, this can be a nice tool to make sure that nobody screws things up by typing it in the wrong way. I'm going to use this as an example with the quantity here, because this is one thing that I do not have a lot of restrictions on. I'm just allowing people to type whatever they want right now. So they could type 3, and that of course won't work. So what we do with this is we highlight all the cells that we want to control. Then we will go to data, and a little bit to the right of halfway, we see data validation. Now I am going to go to the data validation option there, and we're going to go through the options that we have available for us here. You can use this on any cell or group of cells, and you can use it to put in whatever restrictions you want, but typically you would do this in a place where somebody is trying to put in numbers that are going to be calculated in a certain way. So we see we have 3 different tabs here in the data validation screen. And by the way, again, if you'd like to read along, I have this on page 7 of your handout into page 8, and I go over some basic rules for what I would recommend that you do. But we're going to go through this bit by bit here. Settings. So what are we allowing with this? Right now it's set to allow a whole number. We can change that to whatever we want. By default, it will say any value. That's what it will start out with. But if we set this to whole number, that means you can only put in counting numbers, 1, 2, 3, 6,047, but you can't put in decimals, you can't put in fractions, you can't put in negative numbers. If you wanted to allow decimals for something where people could put in $ values, for example, you could choose that. If you had a list of available options, you could create that list. So if there are just a certain number of branches that you were choosing from, you might create that. If you wanted dates or times to be entered in, that's fine too. You could put in text length where you had an exact number of characters that could be entered in. This is something, say, if you had standardized forms that we're putting in that could be exactly 14 characters long, you could have that. And then you could go into custom where you would control something that's a little bit beyond the scope of what we're doing today, but you can put in exactly what you wanted with that. That's getting almost to be Microsoft Access level of control. Most of the time, something like whole number is going to work out just fine for you. This is an important checkbox here. You almost always want to have it ignore blank cells. Otherwise, you would immediately get a bunch of errors for all the ones that have not been filled in. So ignoring blanks is usually what you want to go with there. Now, what kind of whole numbers can be entered in? You could have it between a certain range. So if you've ever filled out a form online and you had to put in a birthday and they don't allow you to be born in 2027 and they don't allow you to be born in 1823, that's a situation where they would have a validation control where it had to be between certain ranges. In this case, we might want to say, okay, people can put in a quantity of things between 0 and 100, but we won't sell over 100 items. You could also say not between. So if there's a specific range that you could not hit, you could do that one. I haven't had a lot of instances to use that in my life, but it is an option available. You could say equal to, and you could give certain values that are allowed. Not equal to for values that are not allowed. Greater than is a very common one. That's what I'm using here. It has to be greater than 0. So you can't order 0 umbrellas. You need to order 1 or more of them. Less than, if you had a limit that things could not be over. Greater than or equal to if you wanted to start with the possibility. So you could say has to be at least 1. Or less than or equal to. In this situation, greater than or equal to are the sensible ways to go. So I'm going to say 1 there. Now, we could just say OK and say we're done. But I want to go through these other options here to show other controls that we have available to us. So if I go to input message, what this is doing is while you are typing, you can put in a message to appear to indicate what you should do. Now, I think the idea of a quantity is relatively straightforward here, and people will probably be able to understand it. But if I wanted to change that, I could put in the title, how many do you want? And an input message, this is where you'd type in the number of your order. Again, I could say OK if I was done here, but I'm not quite done. I want to go through the error alerts. What we're doing here is we are creating a message that will pop up to explain what is going on as we fill this in. We'll see this when we're entering it in just a moment. Finally, the error alert. What do you want to have happen when somebody breaks the rules? When they type in something that is not following the restrictions we put in the settings, do we want to show this error alert after invalid data is entered? Yes, we do. I want to leave that checked so that this actually pops up. And what kind of alert will it be? You can have it stop the person so they cannot enter in invalid data. That's the way I'm going to go with this to make sure that they have to put in something that works. You could give them a warning saying, hey, are you sure you want to do this? Or do you want to go back and change it? You've probably seen those at times when you filled out forms in the past where it's popping something up suggesting that maybe you want to go back and make a change. Or finally, you could have it just be an informational bubble that appears saying, this is not what you were expected to type in. In our situation, I'm going to go with stop, but I'd encourage you to try checking out something different on your own as you play through. The title would be, that's not a number. All right, now that I filled in all 3 of those tabs, I'm going to say OK. And you see, normally we don't have that message coming up, but when you get to quantity, it pops up the information one, how many do you want? This is where you type in the number of your order. And if I type in 5 and press enter, an error appears. That's not a number. You need to enter in a whole number here. So I will retry and I will type in 5 and then it works. So that is how you use data validation to control what you've entered in. Now, the next thing that I want to show you here is what's called conditional formatting. So data validation allows us to control what's entered in. Conditional formatting is not going to actually change the content of our data. What it's going to do is it's going to highlight or change the appearance of data depending on its value. So normally when we do formatting, we are just changing the look and feel of something. If I were to highlight this column, go to the Home tab, and italicize it, that would change that look, turn that off. I could change the color coding. These are different appearances or formatting changes that we could make. Make it bigger or smaller, whatever I wanted to do with that. Conditional formatting is a little bit more interesting. Conditional formatting, I'm going to do that for the totals here, allows us to have the formatting change based on the values that come in there. So I'm going to go into conditional formatting here. You see this is in the Home tab and a little bit more than halfway across from the left to the right. After I highlight that, you're going to see a lot of built-in rules that I can use if I want to. This is something that is in the newer versions of Excel. If you have an older version, you might not have this. You might have to just go to the new rule option that we'll look at together. But there are a lot of color scales and options that we can just grab from this. And I'd encourage you to give those a try and play around with them. They will do things like highlight the top 10 items, top 10%, etc. So if you have a larger spreadsheet that has a large number of data in here, say lots of entries, you could highlight the top 10 sales that you had in there, the top most active salesmen, people who have worked the most, who have been there the longest, the most hours worked amongst your staff. Whatever it is that you are measuring here, you can pull out chunks of it with these top and bottom rules. You can use color scales to emphasize one way or the other, or you can go into the new rules yourself and you can choose some of the options here. So do you want to format all the cells based on their values? Format only cells that contain certain ranges? Format only the top or bottom? Lots of different options to play around with here. Format only unique or duplicate values. This is a special case one, but this can be a really useful tool to, when you've merged data together from a lot of different places, to grab only the duplicate or unique values and pull those out so you can find them easier. So this can be a really nice one. Now, whichever thing you are choosing here, after you have selected it, you will choose a format to apply. So if you're only doing the duplicate values, you would then go into formatting and say, make them bold so that they stand out, or bold and italic so they really stand out. I want to do format all the cells based on their value, and I'm going to do a 3-color scale so I can see a range of scales change based on the percentages. So I'm going from red to green with yellow as the midpoint. So that's what I'm going to go with here. You could change all of these. You could change this from lowest value to be based off of percentage. You could change the color coding however you wanted it to be. Whatever you wanted to do here, you could go with just 2. So it goes from one to the other, and it skips that middle color coding. However you like it. I'm going to say OK to that. I'm going to change this to red so it stands out a little bit more. And after I say OK, I'm going to save time, instead of creating all of these, I'm just going to enter in a couple of different numbers here. And you see, as I enter these in, they get color coded based on their value. So this is a quick way to highlight things that are, perhaps performing not as well, or that definitely want attention. Lots of things that you can do with this. I did it here based off of dollar value that's coming in for the totals here. You can do these off of dates, so you could have the oldest things be highlighted in certain colors. You could do this off of quantities, so you could just have the larger items draw your attention faster. It's not, again, changing the value. It's drawing attention to the information in the way that you want to do so. And you can create several of these rules in different areas to draw the eye to whatever data is important to you. So these, again, while not exactly writing formulas, these are working with the results of your formulas to either keep them more under control by controlling the inputs that are given, or to show the values in a way that draws the attention faster. So those were some tools related to formulas. I hope you found that helpful. Formulas are a really big topic, and they're something that we're definitely interested in talking more about. If there are things you'd like to see more or less discussed in these classes, absolutely let me know. You can contact me here at the library anytime. My name is Sean. I'm the Computer Services Department Head. You can reach me at 630-924-2766. Contact us anytime about any classes you'd like to see or topics you'd like to see emphasized more. The library is now open. Come by anytime to ask questions, and we're happy to help you out as best we can in the lab. Thank you again for your time, and have a great day.